Hello everyone, this is Jason, and next I will introduce you the features about our solar pump inverter. So if it's not that time now. If you will, you can take 5 to 10 minutes to rest. And I will go into this present my PPT in 10 minutes. 鼠标没了。Today, it's my honor to present you the main features about our solar pump inverter and show you how to use our inverter. And why we need the pump protection. And this is a typical solar water pumping application site. Once the pump has been installed, there's no way to observe the running status directly. When the solar panels cannot offer sufficient energy, or there's lack of water in the well, the pump is easily damaged due to idling or running at low speed for a long time. And so, VEICHI solar pump inverter could provide multiple pump protection to protect the pumps in various abnormal situations. The first is sleep protection. As you know, the intensity of the sunlight affects the energy output of PV panels. The sleep protection function means that when the weather is bad or cloudy, the output of solar panels is too low to supply enough power to drive the pumping system. And at that time, VEICHI inverter can detect the burst voltage. And once the burst voltage is lower than the setting value of F14.11, and the inverter will stop and display 8 LPM. And when the weather becomes sunny and better, the voltage is getting higher and higher. Once it's higher than the value of F14.12 and lasts longer than the time set by F14.13, the inverter will restart. Here is a video to show you how this function works. Hey. Let's watch the video. Okay, next I will introduce the low frequency protection. And when the pump is installed in a deep position, and due to the MPPT function, our inverter will adjust the output frequency according to the sunlight status. And when the weather is getting cloudy, and the output frequency will reduce. And in that time, when the pump runs at low frequency, it could not offer enough power to pump the water out and make the model idle and heat up. So model running at idle for a long time without sufficient cooling water will cause the motor to overheat. Similar to sleep protection, the principle of low frequency protection is when the output frequency is lower than the setting value of F14.14 and lasts longer than the time set by F14.15, the inverter will stop and display A.LFR. After waiting for the time set by F14.16, and the inverter will restart again. And then now let's watch this video to show how this function works. Next is dry running protection. Dry running is a very common scheme in application site. After the pump has drained the water in the well, the motor does not have enough water to cool down. When motor running at idle for a long time without sufficient cooling water, that will cause the motor to overheat and increase the aberrations. Based on the above application scenarios, we have designed the dry run protection. When the output frequency is less than the setting value of F14.17 and lasts longer than the time set by F14.18, the inverter will stop and display A.LUT. And after waiting for the time set by F14.19, the inverter will restart automatically. And let's watch a video to show how this function works. I'd like to introduce the waterfall field function. And we can see from the image, there are the X-terminal diagramming. And through the float or water level sensor, the inverter can start or stop automatically according to the water level. And we can see from the format, the F14.20 is the full field detect time. F14.28 is the restart time. And the X3 and X4 terminals are the waterfall field detection terminals by default. And generally, there are two kinds of different sensors. The float switch on the left, the level sensor in the middle or on the right. Usually, first let me introduce the float switch. Usually, the float switch has 3 lines, the brown, blue, and the black lines. Black line is a common line. As you can see on the left image, in the float switch solution, we connect black line with COM terminal. Brown line connect with X3, X4 terminal at the same time. And when the ball is flowing up, and after the time set by F14.27, the inverter will stop and display A.FUL. And on the contrary, when the black line connect with COM terminal, the blue line connect with the X3 and X4 terminals at the same time. When the ball is sinking down, and after time set by F14.27, the inverter will stop and display A.FUL. And for the dual level sensor solution in the middle, when the water level is higher than the position sensor, high position sensor, the inverter will stop and display A.FUL. And the water is lower than the low position sensor, the inverter will restart again. And if the sensor is installed in the tank, this function could be used as a tank full field protection. And if the sensor is installed in the well, just like the image on the right, this protection could be used as the dry running protection. Now let's watch the video and take the example of dual sensor solution to understand how this function works. Welcome back. Let's introduce the minimal power protection. Just as its name implies, when the inverter output power is less than the value of F14.23, and last the time longer than the time set by F14.24. The inverter will stop and display A.LPR. And after waiting for the time set by F14.25, the inverter will restart. This function is specially customized for a pump factory customer. It could work as another kind of dry running protection. And here is a video to show you how this function works. Okay, let's continue. In some special cases, for example, when the rated power of inverter is 1 or 2 levels larger than the pump rated power, so the default overcurrent protection of the inverter cannot protect the pump when the pump is blocked or encounter other failures. And when the output current is higher than the value of F14.20 and lasts longer than the time set by F14.21, the inverter will stop and display A.OLD. After waiting for the time set by F14.22, the inverter will restart automatically. Now here is a video to show you how this function works. Okay, above all is almost the 6th protection of our solar pump inverter. And when the sleep protection, low frequency protection, dry running protection, overcurrent protection, minimal output power protection, waterfall field protection, all these 6 alarms disappeared, we can select 2 kinds of different deceleration modes by setting F14.53. When we set the 10 digits, set 1, it means the free stop. And when we set 0, it means the deceleration stop mode. And in the deceleration stop mode, we can adjust the parameter F00.15 to adjust the deceleration time. And when all these 6 alarms occurs, our inverter will output digital signal by setting F02.44. And the digital output terminals, the Y terminal with COM is a group, TATC is a group, will be activated and output the alarm signal to light up the corresponding fault indicators. You can see from the image, the Y terminal is connected with the 24 volt, and the TATC will be connected with a solar fault indicator with the 220 volt supply. Next is flow data statistics. You can see from the graph on the left. There is a power flow curve, for example. And usually this curve you can get from the pump factory, and we can know the cumulative flow calculated by this curve. But if you don't get this curve from the pump factory or your supplier, don't worry. Our inverter software is able to simulate this curve. This main principle and the process is that first, we can use a flow meter measure this five group of the flow rate at different output power. Then we can know we can get the 5 group parameters shown on the left, and our software will calculate this curve by these 5 points, and we can know the cumulative power flow. And for one more, we need to pay attention is that the unit of these 2 parameters, C02.34 and C02.35. The unit of C02.34 is cube meter, and the unit of the C02.75 is kilo-cube meter. So the formula of the cumulative flow is the value of C02.35 multiple 1000 and add the value of C02.34. 卡住了。 This is a single-phase pumping setting. Previously, when we drive the single-phase pump, we need to change these 3 parameters on the left. First is close the output loss phase protection. Second, we need to adjust the VF curve. The third, we need to raise the low frequency protection threshold. But now, after the latest upgrading, we just need to change one parameter, F14.00. When we set F0.00, the 10-digit number to 1, we can access to the single-phase motor mode. On the right, you can see there's two different types of single-phase pump wiring. We all know the single phase has a capacitor. So if the pump has a capacitor, usually there are 2 lines, the LN lines. So you just need to connect LN lines with any different 2 phases. For example, UV UW or WV. But if you remove the capacitor, there will be three lines, the U, L, N, and the common line, three lines. At this time, you just need to connect these three lines with UVW terminals. That's the diagramming of the single-phase pump. Here is the boost function. We have the input boost module for the model of SI30 D3 2.2 kilowatt B model. And the B model means that the inverter has a built-in the boost module. And this module can raise the bus voltage from under 200 volt to 300 and 350 volt. And at that time, this module could provide enough voltage to drive the 220 volt pump. And in some tiny pump system, for example, if the pump rated power is 350 volts, the rated power is 220 volts. And we use the PV panel. The VOC of the PV panel is 49 volts. The VMP of the solar panel is 40.7 volts. The PM is 390 volts. If we need to drive the 220 volt pump, we need at least we need to make sure the VMP higher than the value of 320 VDC. So for the standard panel configuration, it will need at least 8 pieces panel to get the enough bus voltage. But if we use the model SI30 D3 2.2 kilowatt B model, we only need 4 pieces panel at least. And in some other areas that sunlight is not strong, it can be need 4 pieces at least. And after the comparison, we can know that the benefit is that by using this B model built-in boost module, we can significantly save the cost of the solar panels. Next, I'd like to introduce the VLDC system. VLDC is a new low-voltage, high-efficient solar water pumping system. Comparing with the single-phase pump, the VLDC required only from 12 to 200 VDC for the solar panel. That means it will only need 2 or 4 pieces panel at least. That means it can saving a lot of the cost for the solar panels. And this system don't need debug before your installation, and it can run directly when you install the pump. And with the built-in MPPT function, the controller can just adjust the running speed automatically. And the controller of the solar pump, VLDC solar pump, is IP55 waterproof. That means it could be installed outdoors situation or just under the panels. Next, this is the diagramming of the VLDC controller. We can see from the image, the positive and the negative terminals of the controller are designed with MC4 connectors, which can offer quick connection with PV panels. And the VLDC pump adopt the permanent magnet model. This is a kind of high efficiency model and can consume less energy to provide better head and flow rate. The max speed of the solar pump can reach 4,000 RMP. With the built-in water level control function, this solar pump can run or stop automatically by receiving the level sensor signal. Just the image on the left. This I will introduce the PID control. PID control is a common method usually used for process control through the proportional, integral, differential, and other series operations to compare the difference between PID given value and the feedback value. This is the logist diagram on the left. You can see from the PPT. This PID control function can adjust the output frequency of the inverter to make sure the feedback value is consistent with the given value. And with this function, our inverter could commonly used in constant pressure water supply application scenarios. For example, the dripping irrigation that you can see on the left, and the household compressor water supply. This is you can see in the right image. In order to provide a smarter constant pressure water supply and to meet the further demands of diverse application scenarios, in the latest upgrading, we have added the sleep function into the software. The main principle is when the water consumption becomes small, the pump speed will be reduced, and it can enter the sleep mode when it does not need to run at low speed for a long time. The main principle is that when the output frequency is lower than the setting value of F11.13 and lasts longer than the time set by F11.31, the inverter will stop. And when the pressure feedback value is higher than the setting value of F11.32 and lasts longer than the time set by F14.33, the wake up delay time, the inverter will resume to run again. Next. Next, I'd like to introduce the intermittent running function. As you can see from the PPT, this feature allows the pump to run intermittently to meet special application requirements. How about the so-called intermittent operation? It means that the pump can run for a period of time and stop for a period of time, and then run this way, circle and circle. You can see from the image that the pump can pumping water for a period of time and stop, and when we'll restart again, and circle after circle. And for example, we can set the parameter group as the following shown in the image. First, we set F14.00 to start this function, F14.53 to 4 zeros, F14.145 to 4, F14.55 to 16, F14.56 to 13. That means the inverter will run for 6 minutes and stop for 30 minutes and make the 4 circles. Now, this is a pump cleaning function. We all know when the water is turbid or muddy, the impeller is easily blocked by the sand and the gravel after a period of operation. So, we need to clean the pump impeller regularly to extend the working life of the pump effectively. This process of pump cleaning could be simplified, as you can see on the graph on this image. The pump can run forward for a period of time, and the reverse rotating for a period of time, and then continue for several cycles. Yeah, we can see from following the process. First, we can set F14.00. Then we can set for F14.58, F14.57, and F14.59. This inverter can rotating forward for some time and reverse rotating for some time, and to clean the impeller. And just like a washing machine, to clean the mud and the stones from the impeller. Here is the solar light sensor solution. We know our VEICHI solar pump inverter could provide AC, DC automatic switching. With these two kinds, we can see there are two kinds of light sensor. The first is the illuminance sensor, and on the next is the radiation sensor. Both sensors can convert the light intensity to 4 to 20 milliamps analog signal. And our inverter can receive this signal through the AI terminals to determine the intensity of the sunlight. And after receiving this signal, inverter could control the TATC relay terminals to turn on or turn off, to connect the AC power or disconnect the AC power. And once the sunlight is weak, the inverter will change to AC power supply compensation mode. If the sunlight is strong, the inverter will use only solar power. So this solution will use the solar power in priority and provide 24 hours uninterrupted operation. Here is the diagramming of the solar light sensor solution. As the figure shows, the main principle of the AC-DC automatic switching solution with light sensor is that when we know the stronger the sunlight, the greater the analog signal. So when the weather is cloudy or in the evening, the sunlight is very weak, and the input analog signal will be very small. And if the signal value is less than the value of F03.14, the AI low-level setting, and lasts longer than the time set by F02.48. This is the output delay time. The relay TATC, KA, KM will be activated, and the AC power supply will be connected with RST terminals. Now the inverter can use the solar panel and the grid power together. That means at that time, the inverter could be the AC and the DC compensation power supply mode. But when the sunlight is getting strong, that means the analog signal from the light sensor will get higher and higher. Once it's higher than the value of F03.13, the analog high-level setting value, and lasts for the time of F02.48. This relay TATC, KA, KM will be off, and the AC will be disconnected with RST terminals. And at that time, the inverter will be only use the solar power. And okay, that's all for my presentation. Thank you for your listening. And that's all for our first part of today's training. Next, we will take brief videos. And we will come back at 6:30 p.m. Chinese time. And at that time, we will begin our second part of our training. Then Mr. Carr will introduce the hardware and the wiring of VEICHI solar pump inverter. And Ms. Tennant will introduce the fault debugging and the troubleshooting. Yeah, that's all. Thank you. See you then.